So we stopped and left off in the last video with the iron carbonate, and since I was kind of in the middle, I'm just going to start this problem over again. So we look at this compound Fe2CO3. Now when we have the transition metal in the compound, I'm going to encourage you to always start by writing down the charge of the anion. In this case, it's polyatomic ion. So I'm going to go ahead and look at my periodic table, and CO3 again is a -2 charge. You don't have to memorize that, you just need to know to look for it. So the charge of the carbonate is a -2. Now since there are 3 carbonate ions in this compound, 3 times -2 would be -6. This means that each of these polyatomic ions is gaining 2 electrons, so 3 of them would be gaining 6 electrons total. Now if 6 electrons are being gained, 6 electrons must be lost. So let's write the positive charge over here. Now, since there are 2 iron atoms in this compound, 6 divided by 2 would be each one is losing 3 electrons. So now this is my charge of my iron, of each iron atom. And I'm going in this little roundabout method, always writing down 1, 2, 3, 4 numbers to help me name this ionic compound involving a transition metal. So my name here is iron 3. Don't write down the number of them in there, write down the charge. And carbonate. Okay, let's go over here to practice 2. Predict the ionic formulas that form between the following pairs of elements. When you're predicting these ionic formulas, I think it's always helpful to write the charge above the separated ions here. So lithium and nitrogen. If you look at our periodic table, lithium is in the column of the +1s. The alkaline metals like to lose 1 electron, and nitrogen is in the group 5A here, which like to gain 3 electrons each. So this would be a -3. So lithium is a +1, nitrogen a -3. So the way to balance out these charges would be to have 3 lithiums and 1 nitrogen in the compound. Okay, what about beryllium and chlorine? So beryllium is in the alkaline earth metals. These are +2. Chlorine is in the halogen group. Those are -1. They like to gain 1 electron to become stable. So we have a +2 and a -1. To balance out these charges, we're going to have 2 chlorines and 1 beryllium. Okay, what about sodium with sulfur? Sodium is in the +1 alkaline metals. They like to lose 1 electron. And then sulfur was over here in the group 6A, and they like to gain 2 electrons, so -2. So we have a +1 for sodium, a -2 for sulfur. The way to balance out these charges would be to have 2 sodiums. Okay, for problem 2, identify the charge of the metals in the following compounds. FeCl3. FeCl3. It's a transition also. Let's write the charge of the anion. Chlorines are -1. 3 times -1 is -3. The opposite of -3 is +3. And since there's 1 iron atom in this compound, 3 divided by 1 is 3. 1, 2, 3, 4 numbers. +3. What about FeCl2? In FeCl2, chlorine still -1. 2 times -1 is -2. The opposite of -2 is +2, and 2 divided by 1 is +2. 1, 2, 3, 4 numbers written down, +2. What about CuNO3? Even though NO3 is a polyatomic ion, let's not change our strategy here. We look on our periodic table, we find NO3. NO3 is the nitrate ion, and it's a -1 charge. Now be careful here. There is only 1 NO3 in this compound. Now remember, if there were more NO3s, we would list it outside of parentheses. So I think it's very common that someone multiplies 3 by the -1 here, but there is only 1 NO3 here. 1 times -1 is -1. The opposite of -1 is +1. And there's only 1 copper atom in this compound, so 1 divided by 1 is +1. Lastly, PbO2. The charge of the oxygen ion would be -2. 2 times negative 2 is negative 4. The opposite of negative 4 is positive 4. And 4 divided by 1 is plus 4 each. Okay, let's finish this off by naming these following compounds. SR3N2. This is a main group metal with a main group nonmetal. Let's just go ahead and start naming it. Strontium, and then end with the root I, nitride. We don't need any prefixes here, and we don't need any Roman numerals because this is a main group metal. Okay, MgSO4, main group metal with a polyatomic ion. Let's go ahead and look SO4 up. SO4 is sulfate. We don't have to memorize that. We just need to know to look it up. So we just have magnesium sulfate. Make sure to end in 8, not "ide." Na2NO2. Oops, you know what? It should just be NaNO2. We have a main group metal with a polyatomic. So NO2, let's go ahead and look that up. NO2, it looks like, is the nitrite ion. So we have a main group metal, so just name it, sodium. And NO2 is nitrite. ITE ending. MnNO32. Okay, so here we have a transition metal. So I think we need to do that little roundabout method, writing down the 4 numbers. So we have NO3 here, the nitrate ion. NO3 is nitrate and it has a -1 charge. Now, in this compound, there are 2 nitrate ions. So 2 times -1 is -2. The opposite of -2 is +2. And there's 1 manganese atom or ion in this molecule. So I would say 2 divided by 1 is 2. So I would call this manganese 2 nitrate. Okay, lastly, PbO. In this compound, the oxygen is a -2. And again, I'm find the Roman numeral for this because lead is one of the metals. It is a main group metal, but it's on that lower right side, so we're going to want to indicate its charge. And we'll kind of practice when we're going to name those main group ones with a charge or with a Roman numeral. So the oxygen is a -2. There's only one of them here, so 1 times -2 is -2. The opposite of -2 is +2, and 2 divided by 1 is +2. So this compound would be called lead 2 oxide. Okay, I hope this one helped.